Okay, let us study about center of curvature. What is center of curvature? See, curvature already we know. We want center of that curvature. But how to find it? Suppose we have a point on a curve. Let the point P. Whenever the point move from P to Q, there is a small change in the position over the curve. Definitely directional. It means that points draw tangent at P and it makes an angle psi with the x-axis. Similarly, if you draw tangent Q, it makes an angle psi plus delta psi with the x-axis. The whatever the change in the tangential direction is delta psi. This represents a small bending of the curve over that small distance. If you divide that small tangent change in the this delta psi by small arc length ds between p and q, we can get the rate of change of time with respect to arc length, that is called as q tends to p. This is what gives curvature at that point, means amount of bending at that particular point, the rate of change of amount in bending that particular card. And how then very interestingly that I can say that which is equal to the I can say that reciprocal of the radius of curvature, because as the change in the tangential direction, then delta psi, which is equal to the angle subtended by the which is equal to the angle subtended at the center of this circle by this small length between p and q, that is called osculating circle. Means what? If the circle which approximates that curve at that point is called osculating circle, and whatever the small arc becomes almost part of the circle, that is called osculating circle. The radius of that circle is osculating circle is radius of the curvature at that point. Similarly, the center of that circle is called center of the curvature. Means we want the center for curvature, means which is curvature becomes part of that circle. That curvature small part, which you can say that becomes a small part of the circle, because therefore whatever is the center of the osculating circle is nothing but the center of curvature of that at that particular point. This is basic idea, we should know that. And already we know that whenever we find out the radius of curvature, we already studied why this curvature equal to the reciprocal of the because the change in the tangential direction is equal to the angle subtended at the center by this small arc pq. And this is why, and this I can say that whenever the I can say that this becomes equal to the d theta. Now d theta is equal to d psi, and we already know that s is equal to r theta, and already we know those things. Therefore it becomes in the previous classes we studied. Now we can come to conclusion that the center of the osculating circle is the center of the curvature. Now how to find it? We have to go further. Suppose we have a, if the given curve, let the point p be p of xy. They ask to find out the center of curvature at that point. As I told you, the center of osculating circle at that point is nothing but the center of curvature. I mean the now only as we discuss that. Let us assume that there is a circle which is best approximate at this point. The center is I can say that alpha and beta, and definitely this radius vector is, and radius of that circle is ultimately definitely perpendicular to the tangent. If you draw tangent at that point, they given a curve, and coordinates may be x comma y, and cbd is center of curvature means the center of osculating circle, we can say that, no problem. And if the tangent makes an angle psi with the x-axis. Now if you draw perpendicular pn and cm perpendicular to the x-axis, and pr perpendicular to the cm, now this construction we can make it with whenever this curve on a and curve is given and p is given, these construction we can make automatically, no problem. Okay. After this construction we want this center, but thing is very important, this angle is this also becomes psi. Why? Because whenever this angle is psi, the alternative interior angle property, this angle is also becomes psi, because this is rp is I can say that parallel to this x-axis, because I can say that and because RPN is becomes rectangular because all are 90-degree here, because we are drawn here perpendicular, and RM, RPN are also perpendicular, and RP is also perpendicular. Therefore, we can say that these are the we can say that what we can say, this angle is also, this RP is parallel to this one, alternate interior angles. You can say that this angle is also psi. Whenever this angle is psi, we know that CP is perpendicular to this tangent. This becomes 90 minus psi, and this is 90 means the automatically the sum of one angles in triangle become, this becomes psi, because 90 minus psi plus 90 plus these angles maybe we can call CRP is equal to 180-degree. Definitely CRP becomes a psi here. Okay, this is how we can prove it. This is angle is psi. What this is why we can say now we can find out easily the center of curvature in a very easy manner. What is the center of curvature? We can say that alpha is equal to, we want the distance from O to the P in Cartesian form. OM, we want OM can be written as ON minus MN, but MN can be written as, these are perpendicular, can be written as PR, and PR is nothing but the based on this CP sines psi, because this is called opposite divided by hypotenuse. Hypotenuse is nothing but the radius of curvature here, and that is CP is nothing but the radius of curvature here, sine phi as it is. Therefore, alpha is equal to x minus rho sine phi. Similarly, beta is equal to MC here. Beta is equal to MC, and MC can be written as NP. And instead of NP, we can write RM. CM can be written as RM plus CR, but RM can be written as NP. NP is nothing but the Y, and RC is nothing but the rho cos phi, because cos psi is equal to adjacent divided by hypotenuse. Adjacent is I can say that we want actually adjacent is equal to rho adjacent is equal to CP into cos phi, that is CP means rho, that is radius of curvature, into cos phi. Now with these values, but we know what is the sin phi, sin psi and cos phi, but how to find out? Already we know that tan phi is equal to dy by dx, and rho already we already stated how to find out the formula for that is 1 plus dy by dx whole square raised to 3 by 2 divided by d square y by dx. We have already find out this, and how to find out sin phi and cos phi, that is tan phi is equal, tan psi is equal to dy by dx. From that we can find out sin psi and cos phi, cos psi. See here basically 1 plus tan square, whenever we know that tan psi is equal to dy by dx, and 1 plus tan square is equal to second square psi, and we call this dy by dx is equal to m, 1 plus m square is equal to second square psi. Therefore we can say that cos square psi is equal to 1 upon square 1 divided by 1 plus m square. Cos psi is equal to 1 divided by square root of 1 plus dy by dx square. And similarly, we want to find out sin psi, that is equal to tan psi into cos psi, that is equal to, finally we can get it, sin psi is equal to dy by dx whole divided by square root of 1 plus dy by dx square. Okay, this is how we can find out sin psi and cos psi. Then after that, and already we know the radius of curvature in Cartesian form, that is 1 plus dy by dx whole square raised to 3 by 2 divided by d square y by dx square. Therefore we can apply here, we know the rho value and the cos y value and sin y value. If you substitute back, you can get this final result. After, with these things, we know the center of curvature, one center and uh, of a circle we know, and once there is a common point P of xy, we can write the equation of the circle of a, that osculating circle of that curvature at that particular point, that is called x minus alpha square plus y minus beta square into rho square. That is, rho is the radius of curvature at that point. This is how we can understand. Thank you.